Have you ever watched a car zoom past you on the road? Or timed yourself running from one side of the school to the other? Or maybe you've seen a roller coaster flying up and down the tracks. Whether you're running, walking, riding, flying, or even sitting still, you're always part of something called motion. And today we're not just going to learn about motion, we're going to understand it, measure it, graph it, and even predict it like real scientists. So buckle up, because this lesson is going places. So, what is motion? In simple terms, motion means a change in position over time. If something moves from one place to another, whether it's a soccer ball, a rocket, or a butterfly, it's in motion. But here's the twist. We always describe motion in relation to something else. This is called a reference point. If you're sitting in a moving bus and you toss a ball in the air, it looks normal to you. But someone standing outside the bus might see the ball making a curved path through the air. That's because motion depends on your point of view. Scene 2, distance versus displacement. Let's talk about two important ways to describe how far something moves: distance and displacement. Distance is the total path you travel. It doesn't matter which direction you went, it's just how much ground you covered. Displacement is the straight line from your starting point to your ending point. It includes direction. Example, you walk 3 kilometers north, then 3 kilometers south. Your total distance is 6 kilometers. Your displacement is 0 kilometers. Why? Because you ended up right where you started. Think of distance as your footsteps, and displacement as the straight arrow from start to finish. Scene 3, speed, velocity, and acceleration. Okay, now let's make things interesting with speed, velocity, and acceleration. Speed is how fast something moves. The formula is super simple. Speed equals sign distance time. So if you ran 100 meters in 20 seconds, speed equals sign 120 s equals sign 5 m per s. But speed doesn't tell us which direction. That's where velocity comes in. Velocity is speed with direction. So if you say 5 m per s north, that's velocity. Example, two cars move at 60 kilometers per h. One is going east, the other west. Same speed, different velocity. Now let's step it up one more level. What happens when speed changes? That's called acceleration. It's how quickly you speed up, slow down, or change direction. The formula is acceleration equals sign change in velocity slash time. Example. If a car goes from 0 to 100 kilometers per h in 10 seconds, it has a positive acceleration. If it slows down, that's negative acceleration, also called deceleration. Scene 4, graphing motion. Now here comes the part that makes scientists and math teachers super excited: graphs. Let's talk about how we can visualize motion using distance time graphs, velocity time graphs, distance time graphs. On these graphs, time is on the x-axis, horizontal; distance is on the y-axis, vertical. A straight line going up means steady speed. A flat line means the object is not moving, it's at rest. A steeper line, that means faster speed. A curved line, the object is accelerating. Imagine you're jogging, your line goes up slowly. Now you start sprinting, your line gets steeper. Then you stop to tie your shoelace, it goes flat. That's motion. On a graph, velocity time graphs. Now we switch it up a bit. Time is still on the x-axis, velocity is on the y-axis. A straight horizontal line, constant velocity. A line going up, positive acceleration, you're speeding up. A line going down, negative acceleration, you're slowing down. A line at 0, no movement. These graphs are super helpful for analyzing how motion changes over time. Let's bring this back to real life. Motion isn't just something we read about in science class, it's everywhere. Trains, bikes, planes, motion, a skateboard going downhill, acceleration, a soccer ball kicked across a field, displacement, speed, and velocity in one. Even your heartbeat and breathing involve motion. Even atoms are constantly moving on a super tiny level. Understanding motion helps engineers build rockets, helps doctors study blood flow, and even helps athletes run faster. Closing and challenge. Alright, motion masters, time for your challenge. Measure how far you can walk in 10 seconds. Calculate your speed. Try it walking, then running. Graph your motion. See the difference. Want bonus points? Try describing your movement using distance, displacement, speed, velocity, and acceleration. And don't forget, next time you see a car, a bird, or even a falling leaf, you're watching the science of motion in action. If you loved this episode, hit like, smash that subscribe button, and stay tuned. Because next time, we're learning how forces make things move, stop, or fly through the air. Until then, keep moving, keep learning, and keep being awesome. This is School Subjects Online, and science just got real.